Assalamualaikum warahmatullahi wabarakatuh and very good evening to my lecturer, Dr. Suraya and my fellow friends. So today, me and my partner IZZAT are going to present to you about the application of kinetic of rigid body for a card. So before we start, my name is Muaz bin Abdul Malek and my metric number is 207529. So let's get started. So what is kinetic of rigid body? Kinetic of the rigid body is the relationship between the external forces acting on the body and the corresponding translational and rotational motion of the body. So before I continue, allow me to remind you that the translational motion of the body is when the object moves in a straight line like this. So for the rotational motion of the body is when the object moves in a circle like this, moving like in a circle. So continue to the topic. Because of our card have a wheel, so it will follow the second Newton's law. But if the card doesn't have a wheel, it will follow the second and third Newton's law. So next, for the application of the card, we use the method of summation of forces, where we calculate the summation of forces at y-axis and x-axis, and by doing that, we'll get the actual forces acting on the object. So before we use the second Newton's law, so we will use the formula of summation of F equal ma, where F is the force, m is the mass, and a is the acceleration of the object. So for the rest of the presentation, my partner is going to continue it. So thank you for watching and enjoy the rest of the presentation.
Hi, my name is NAJMI bin WAHAK and my metric number is 206-870. So I will continue the presentation. So as you can see, there is the two diagram, which is FBD diagram and kinetic diagram. So at the left side of the diagram, there is the FBD, which is it shows all the forces that reacts on the cards, and the right side of the diagram is the kinetic diagram, which is show the force of the movement of the cards. Continue. So to find the so we have to find the NA and NB of the cards and also the acceleration. So we know that the card is moved horizontally toward the x-axis, and we have to summation of fx to find the acceleration, and then from that we get the 4.33 meter per second squared. And then we have to find NA and NB. So we know that NA and NB is react toward the y-axis. So we have to use the summation of Fy. And then from there, we get the NA 219.3 minus NB. So there is term NB in the NA. So we have to use another equation, which is we use the summation of moment, which is it reacts on the point G at the center of the gravity of the card, and then we get the long equation to find the to determine the sign convention of NA and NB. When we leave the cards and when we put some force at the left side of the roller, we know that the card will turn clockwise. So we know that when the object is turned clockwise, the sign convention is negative, and when the anti-clockwise, the sign convention is positive. So it same goes to NB. When we do the same method, we get to find that NB is the positive, and from there we settle it down, and then we get the NB is 162.6 Newton. So from that value, we substitute back at the NA, and then we get the value is 56.7 Newton. So right now we achieve our goal, we achieve our objective, and we finished our calculation. So that's all from our group. So hope you guys like it. Thank you.